Okay, we're talking about proportions. Two fractions equal to each other. So for example, give me a fraction that's equal to a half. 3/6, sure. 3/6. Someone else said 4/8. So does that mean that 3/6 is equal to 4/8? Yeah, they're all equal to a half. Right? So all of these are proportions. Now, you want to say something really cool about every proportion? Are you ready? Look what happens when you multiply the diagonals in each of them. What happens? Haley? Not always. Try the third one. Multiply all your diagonals together. They're equal to each other. So in a given proportion, if I multiply the diagonals, they're always going to be the same as each other. That's really cool. 1 times 6 is 6, 2 times 3 is 6. 1 times 8 is 8, 2 times 4 is 8. 8 times 3 is 24, 6 times 4 is 24. So if you have a proportion, when you multiply the diagonals, they will always be equal to each other. So that's a great way to check. With these, it's easy. I know that 3/6 is a half and 4/8 is a half, but sometimes it's not always as clear. Like I might ask you, do these fractions form a proportion? Let's say I give you these, maybe 5/7 and, I don't know, 6/8. Off the top of my head, I have no idea if they're equal to each other or not. But what I could do is I could, actually, let me put a question mark over this equal sign because I don't know that they're equal right now. A quick check is to just multiply those diagonals and see if I get the same number. So 8 times 5 is 40, 7 times 6 is 42. So are these two equal to each other? No, they can't be. So no, because the product of their diagonals is not the same. And it would have to be if they were to form a proportion. Okay, so let's try another one. How about, I don't know. How about 2/9 and 4/18? Question mark, because I don't know if they're equal to yet. Pablo? Multiply what? Yeah, and do you get the same number? Yeah, this time you do. 18 times 2 is 36, and 9 times 4 is 36. That means, yes, 2/9 and 4/18 really are the same thing. So, yes, these do form a proportion. So that's a nice, quick way to check. Just multiplying those diagonals, see if you get the same thing. Because we can multiply the diagonals to see if they're equal, if I'm missing one of those numbers, I can use that property of proportions to find that missing number. So if I look at a proportion, if I'm missing one of these four, if I don't know what it is, I can figure out what it needs to be in order to make the proportion. Miss Sabia, what are you talking about? I'll show you. Let's say you had, let's go back to the example that I just gave. You have a 4x6 picture, and you are making a new frame for it, and you have the perfect space on your wall, and that new space is going to be 11 inches wide. So let's see, if it's 4x6, wouldn't 6 be the horizontal part? Right? I guess it doesn't really matter. Let's say it's 6 vertical, and 4 vertical, 6 horizontal. You want to have 11 inches horizontally in your new picture. So I need to put 11 in the same spot. So I want my horizontal value to be 11. So now I need to ask myself, okay, well, how long should this frame be to keep my koala looking like a normal koala and not making him a long face or a wide face? So I don't know what that value is going to be. So what I can do is I can use that property of proportions. I can multiply the diagonals And look what happens. What do you get when you multiply 4 times 11? 44. So I'm going to set that equal to the product of the other side, 6x. You get an equation that you can solve pretty easily too, right? I just want to get the x by itself now, so what do? Divide by 6. So I'll just see what 44 divided by 6 is. 7.3 repeating, so that's 7 1/3, right? So if these are inches, my new frame, I should make it 7 1/3 inches long to keep it proportional to my original photograph. Does that make sense? Good. So you tried this one. Let's just say you had something like, oh, I don't know, how about 8/9, and I want to know what should that be if I want the new one to be 20. So, some common questions I get are, Mrs. Sabia, how do I know which diagonal to multiply together first? Doesn't matter. Does not matter. It also doesn't matter if you do 20 times 8 or 8 times 20. Doesn't matter. Just multiply one diagonal, write its answer. Here's another common mistake, is that kids will do this. They'll multiply these together, right, and they'll get 160. Don't write this down, but this is what I see all the time. They do 160, and then they make it a new fraction and put the answer to the other one underneath. Like, what even is that? That's nothing. And that's not what's happening here. That's not going to help you. You want to multiply the diagonals and write them as an equation. They're equal to each other. So when I multiply 8 and 20, I get 160, right? You set that equal to the other side. So what do I get when I multiply the other side? 9x. And now I have a nice, easy equation to solve. And I would solve it by? Yeah, just divide both sides by 9. So we'll see what 160 divided by 9 is. What'd you guys get? Everybody did it, right? Pablo, what'd you get? I think you hit 16 and not 160. Did you say 1? 1 and 7/9? You didn't get 17 and 7/10? Yeah, 17 and or 7/9. Or 17.7 repeating. Did everybody get that? Yeah. Okay. So, proportions are amazing. You use them literally all the time, you just don't even realize it. When you are, have you ever used GPS in the car? I'm sure you have, or you've been in the car when someone had like the navigation on, either on your phone or if your car has it. Do you know what I'm talking about? Are you with me here? Right? Okay, so it's basically just like a mini map of whatever town you're driving through. That uses proportions. It takes the entire map of the town and it shrinks it down to fit on your phone or on your car's screen. Right? Those are called scale drawings. It's all proportional. You follow me? Every time you look at a picture of something, look at the picture of the, I don't know, Mount Rushmore. You see it this big, but in real life, it's ginormous. Even a picture of a person, it's not usually life size. When we're looking at it, it's usually a shrunken down version. But they look the same. It's just a mini version. So it's all using proportions. All right. Now, not every proportion is as easy as these. Sometimes they get a little bit more complicated. For example, you might see something like this. What if you had x plus 3 over, I don't know, 9 equals 2/5? What in the world do you think you do with this thing? Yes. What'd you say? No, you can't because they're not like terms. Yeah. Kaden? Multiply 9 by... Oh, you can do that. You're not wrong, but you're making a little bit more work for yourself than you have to. Guys, as long as I have a fraction equal to a fraction, I'm still just going to multiply the diagonals. I'm still just multiplying diagonal times diagonal. Here's what's a little bit different about this one, though. 9 times 2, well, that's easy. So one side, I get 18, no big deal. But on the other side, when I multiply this diagonal, please watch. Is everybody paying attention? Because this is an important part. Lyric, you with me all the way? All right, watch. So I multiply 9 times 2, no big deal, 18. When I do 5 times x plus 3, this is really how you have to write it. You need to do 5 times all of this. So the only way to show that is to put it in parentheses. Because you need to do 5 times both. 5 times the x and 5 times the 3. So you really get 18 equals 5x plus 15. Do you see that? Everybody okay there? And now, again, I have an equation that I'm just going to solve like I always do. So what would I normally do at this stage? Minus that 15. And then what would I do? Divide by 5. Perfect. So in this case, I don't know why this is fuzzy. There we go. Divide both sides by 5. Looks like my answer is going to be 3/5. Okay, so you try one like this. See if I can leave this up and give you another one at the same time. How about 3 over x minus 2 equals 4, oh, I don't know. Okay, 5ths. Oh, sorry. There you go. Try that one. Okay, we got something? Pablo, what's your answer? 7/4. Any other answers? Everybody got some? Yeah. 6.5. I have no idea what the answer is. Jed? 5 3/4. Oh boy. All right. So let's check it out. So, 3 times 5, that's easy. So one side should be 15. Doesn't matter if that's your left-hand side or your right-hand side. Doesn't matter. The other side, I need to do 4 times x minus 2. So I need to write it as 4 times x minus 2. And now I need to distribute that 4. So you should have a line somewhere on your paper with 15 on one side and then 4x minus 8 on the other side. If you have 4x minus 2, you did not distribute. You have to make sure you multiply both those numbers by 4, not just one of them. So once I get here, I'm finally able to solve like we all know how to do. I'm going to add that 8. So 23. And then go ahead and divide by 4. So you can leave your answer as 23/4 because you can't reduce that at all. But if you want to change it to a mixed number, that's fine. So as a mixed number, yeah, I think it's 5 3/4, right? Because 4 goes into 23 5 whole times to get me to 20, and then 3/4 left over. But again, you can leave it improper, no big deal, as long as it's reduced. Okay, so solving proportions, is it that bad? No, it's not that bad. I want to give you one example of a real life scenario. Every year, back in the day, my friend used to have a cookie baking party. So instead of everybody cooking their holiday cookies at their own house and messing up everybody's own kitchen, we'd all get together and spend the whole day baking cookies together in one person's kitchen and just mess up one kitchen. But then you're hanging out with your friends all day and you get to chit chat and blah, 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 blah. So my friend has this one recipe that called for, I don't know if the numbers are exact, but it was roughly this. I think she needed 35 ounces of chocolate. She had a bar of chocolate. So it was like you were supposed to take like an actual bar and then like shred it. So she had a 40-ounce bar. And you know how when you buy like a Hershey's bar of chocolate and you take the wrapper off, there's like rectangles on it? So she came to me and she's like, hey, I have 40 ounces. The recipe calls for 35, so how many of these rectangles am I supposed to use? Why you don't just throw in the extra ounces of chocolate, I don't know, but whatever. She wanted to stick to the recipe, okay? So let's just say 40-ounce bar with, let's just say that chocolate bar had, let's say it had 15 of those rectangles. I don't really remember, but let's just say it was 15 rectangles. I actually think that they're called pips. You have a rectangle, I'm pretty sure. It's pip, P-I-P. A pip of chocolate is one rectangle from a candy bar. I'm pretty sure. I'll double check them. So anyway, so can you imagine the scenario? She has this bar of chocolate. It's got 15 rectangles. She only wants 35 ounces instead of the full 40 ounces. So she knows, I know my numbers. She comes to me and says, tell me how many rectangles I need, right? So this is just a proportion problem. Okay? So here's how you're going to do it. I usually start with what I have. So she's got 40 ounces and 15 rectangles. So your first fraction, you're just going to put 40 ounces over 15 rectangles. And it actually doesn't matter which one's on top and which one's on bottom, as long as when you set it equal to your next fraction, you match it up. That's all you got to do. So on the other side, she knows she wants 35 ounces. So where should I put 35 on the other side, Haley? I want to match it to what's on the other side. So Pablo, I want it on top. Because I put ounces on top here, so I want ounces on top here. So she wants 35 ounces. So her question to me is, how many rectangles? See how the units match up? Wherever it was on the first side, you just match it up on the second side. And now you guys have the skills to figure this out. So just multiply those diagonals and solve for x. So tell me how many rectangles I should tell her to put in. I gotta tell her that I use her as an example every time I teach this lesson. She'd probably laugh. Huh?
Who has to clean the kitchen?
Well, usually we all kind of clean it together, and then it's done.
If it was my kitchen, I wouldn't make myself clean it. I'd make everyone else clean it.
That's actually not a bad idea.
You should post it at your house now.
I do have 2 ovens too, so. But most of these friends moved away now, so I'm sad. They should come fly up and make their cookies with me, right? Yeah, it's no big deal. Yeah. You have an answer?
Yeah.
Before you say it, everybody look at your answer and ask yourself if it's a reasonable answer. Before you even did any math, right? The whole bar is 15 rectangles. So do I expect my answer to be bigger or smaller than 15? Smaller, because I don't want to use all 40 ounces. I want 35. So I'm going to use a lot of the 15 squares, but not the whole thing. So I'm expecting a number that's certainly less than 15, but maybe not that much smaller. Like if I got 2 or 3, that seems way too small. It doesn't seem to make sense. So Pablo, tell me your answer. 12 and 9/8 sounds like a reasonable answer. I don't know if it's the right answer, but it certainly sounds reasonable. Does anybody else get that same thing? 12 and 9/8? Oh dear.
Wait, what'd you get?
Well, 12/15 you could reduce, right?
Yeah, I got
Well, let's do it. Let's see. So when I multiply those diagonals, right, 40 times x is just 40x. And then 15 times 35, I got 525 for that. Right? And then what do? Divide by 40. So I get 13.125. And these are rectangles. So I'm going to tell my friend to use 13 and a little bit more of one more rectangle.
Let's go.
Though honestly, again, if it's me, I'm just throwing the whole bar in there with 15, because who doesn't like extra chocolate? But okay, so does this make sense? We're all right? Okay.